Namaste children, I am Hari Prasad, the chemistry teacher. Children, today's topic is atomic radius and how it varies when you go down the group. Now children, what are the two factors which will affect atomic radius? We have already discussed these things in the previous video. The two factors are, one is nuclear charge and what is the relationship between nuclear charge and atomic radius, right? As the nuclear charge increases, the electrons in the outermost shell are pulled with what? Greater force, and the size of the atom is going to what? Decrease. That is, can we say that we have a inverse relationship like this? Nuclear charge increases, the electrons in the outermost shell are pulled with greater force, the size of the atom is going to what? Decrease, right? Now, what is the next factor? The next factor is number of shells. As the number of shells increases, right? So children, as you already know that if I hold like this, it is nucleus and this is the outermost shell containing electrons. That is, as the number of shells increases, see, 1 shell, 2 shell, 3 shell, 4 shells, 5 shells. As the number of shells increases, right, the atomic radius is going to what? Increase. That is, the relationship between number of shells and atomic radius is what relationship? Direct relationship. Here it is inverse, right? And here it is direct. Right, children? Now, to understand this variation of atomic radius down the group, I have considered the elements of group 1 of the periodic table, that is lithium, sodium, potassium, rubidium, cesium, etc. I have not considered, right? Now the electronic configuration of lithium is 2,1, sodium is 2,8,1, potassium is 2,8,8,1, rubidium is 2,8,18,8,1. Now children, first we'll see what is happening to the nuclear charge when you go down the group. Now, lithium has 3 protons, that is 2 plus 1, 3. Sodium has 11 protons, 2 plus 8 plus 1. Children, we already know that any atom contains the same number of electrons and as well as what, children? Protons. So, potassium it is 19 protons and rubidium it is, okay, 37 protons. Now common sense says that when you go down the group, the nuclear charge is continuously what? Increasing. So we know that as the nuclear charge increases, the electrons in the outermost shell are pulled with greater force. The size of the atom should what, children? Decrease. Now we'll just see the next factor, number of shells. Now lithium 2, 1. So that is 2 shells. Sodium 2,8,1, 3 shells, 1, 2, 3. Potassium 2,8,8,1, 1, 2, 3, 4. Rubidium 2, 8, 18, 8, 1. That is, when you go down the group, the number of shells is what? Increasing. We know that as the number of shells increases, the atomic radius will what, children? Yes, it will increase. Now children, we'll see what is happening to the atomic radius of these elements by just observing the values. Children, one thing what I would like to tell is that I am writing the values just to make you understand. No need to remember these values for the board exam, right? Now, when it comes to lithium, it is 1.55 Armstrong units. So, sodium it is 1.91 and potassium it is 2.35 and rubidium it is 2.48. Okay, children, 1.55 to 1.91, you call it as what? Increase. 1.91 to 2.35, increase. 2.35 to 2.48, increase. So these values clearly suggest that when you go down the group, the atomic radius is continuously what, children? Increasing. That is, this is lithium, what? Sodium, potassium, rubidium. It's continuously what, children? Increasing. Now the question arises, boss, the nuclear charge is also increasing, no? As the nuclear charge increases, the electrons in the outermost shell are pulled with greater force. The size will what? Decreasing. The size will decrease. But here the size is not decreasing. Instead of that, the size is increasing. The reason what you tell is that, sir, number of shells is also increasing. Fine. But nuclear charge is also increasing, no? Yes. Your textbook clearly says that out of nuclear charge and number of shells, that is, the number of shells dominates over nuclear charge. I repeat, the number of shells dominates over nuclear charge when you go down the group. That's why the atomic radius is going to what? Increase. Right? Now, the question arises, first, what is the meaning of the term what? Dominates? Why it dominates? Why the number of shells dominates over nuclear charge? Children, for this, I would like to take one small demonstration. Children, what we'll do is that I have taken one magnet and one metal. Now, this magnet, right, is nothing but nucleus, which contains what? Protons. And this is the electrons which is present in the outermost shell, right? Now, what I'll do is that, see, when the electron containing outermost shell is closer to the nucleus, right, what will happen? See, observe, right? This nucleus containing protons will pull the electrons, right? See? Now, what I am going to do is that as the distance between the nucleus and the outermost shell containing electrons increases, now we will see whether this will pull or not. In the previous case, it was pulling because the distance was less. When the distance increases, I will leave this one. Will it pull or not? First, it is not pulling. So what is the meaning of this one? As the distance between the nucleus and the outermost shell containing electron increases, the force of attraction decreases, right? Why the force of attraction is decreasing? Because of what? Increase in what, children? Distance. That's why we say the number of shells dominates over what? Nuclear charge. That is, though the nuclear charge is more, it is not able to pull the electrons that is present in the outermost shell because of the increase in the distance between the nucleus and the outermost electron. Why exactly? So you mean to say that as the distance increases, the force of attraction between nucleus and outermost electron will be less. Why exactly? What will happen exactly? Now, children, let me give you an example. You go to a air show, right? Usually air shows are conducted during summer times only, right? Sun, very hot sun, right? So we have to go and stand there. You have to see all those aeroplanes, etc., whatever it is, jets, etc. Now, children, what you do is that in that hot sun, your skin will get what? Tanned. Don't you think so? Yes. So to protect your skin from the sun, what you do is that you apply one lotion. What is that lotion that you are going to apply? It is what, children? Sunscreen lotion. What this sunscreen lotion does? This sunscreen lotion will act as a protective layer between what, children? Sun and the skin. That is, it is going to decrease the interaction between the skin and the sun by acting as a protective layer. Now, children, sir, why you gave that example now? Just observe here, children. Children, we will consider this nucleus as what, children? Sun. And the outermost shell containing electron as skin. I repeat, we will consider this nucleus as sun and this electron containing outermost shell as what, children? Skin. Now between sun and skin, I think we have one more shell. What is that shell? It is K shell. Don't you think that this K shell is acting as a sunscreen lotion? What I am trying to say is that the force of attraction between the nucleus and the outermost shell containing electrons is decreased by the electrons of what shell? K shell. Right? Now, the effect caused by the electrons of this K shell, we call it as what effect? It is screening effect. What do you call this one as? Screening effect. Sir, what is screening effect? A screening effect is nothing but the decrease in the force of attraction between the nucleus and the electrons of the outermost shell by the electrons of what shell? Inner shell. Which is the inner shell in our example? K shell. The effect caused by the K shell, we call it as what? Screening effect. Okay. Now, let us consider sodium, children. The previous example was lithium. Now, we will consider sodium. Now, this nucleus is trying to pull the electrons that is present in the outermost shell, which is present in what shell? M shell. Now, between nucleus and M shell, how many shells are there? Two more shells are there. Which are they? One is K and another one is what, sir? L. Don't you think that this K and L are acting as a screens between nucleus and what? The electrons of outermost shell? Yes, definitely. Now, in this case, only one screen was there between nucleus and outermost electron. Here we have how many screens? Two screens. Now you come to potassium, between nucleus and outermost shell containing electrons, how many screens are there? Three. In case of rubidium, we have how many screens? 1, 2, 3, 4, right? Between nucleus and outermost electron. Now common sense says that when you go down the group, the screening effect is continuously what, children? Increasing. When the screening effect increases, the force of attraction between the nucleus and the outermost shell containing electron will decrease. Because of screening effect, though the nuclear charge is increasing, right? Though the nuclear charge is increasing, the protons present inside the nucleus are not able to pull the electrons that is present in the outermost shell. That's why the atomic radius is going to what, children? Increase. So that's why we say the number of shells dominates over what, children? Nuclear charge. Children, once again, what is screening effect? The decrease in the force of attraction between the nucleus and the outermost shell containing electrons by the electrons of what shells? Inner shells. We call it as what? Screening effect. I hope, children, you have understood this one. Children, according to me, out of the 6 periodic properties, the most important periodic property is atomic radius. That too, the atomic radius when you go what? Down the group. If you have understood this concept thoroughly, then the rest of the chapter is very easy. Okay, children? So, conclusion is, down the group, the atomic radius is going to what? Increase. I hope you have understood this concept. We'll continue the remaining in the next video. Thank you, children. Namaste, everybody.